So these 2 points are one of the two crucial points of any system design, whatever kind of system it is, whether it's a hardware, software, or organization. Everywhere you will see, if there is a system running, you will be able to see the components and the fact that they are working together. In our case, we learned one of the main design that we learned for object-oriented design is class diagram. So inside a class diagram, what we have seen, there are classes, and then they work together by the relationship they connect with each other. So in class diagram chapter, what you learned, how to design a class with its uh, attributes and operations. Then in another diagram, you learned how to connect a class with other classes. So there were two specific type of design that you have learned in class diagram. One was the design of the individual classes, and then how do we make them work together with the help of the relationship. These are the two factors that relates to the system definition, the components, and they work together. So component design is class design, work together design is the relationship design. So in any aspect of system design, these two directly relates to the success of your system. How good the system will be will always depends on two aspects. One is the component itself, because every component will have their own responsibilities. Like if you think about an organization, okay, let's say a business organization, usually how can you find what components they have in that organization? Basically, the departments are the components. Like they might have marketing department, they might have sales department, they might have administrative department, they might have, I mean, uh, let's say transport department as well. So these are all their different components of the organization. The organization definitely has got a set of objective, a target, the goal, a goal they set what they want to be or how they want to reach their target. The task of every department is to work together so that the whole organization can reach that target. But the way they work is individually, every department has separate responsibility. Like the task of sales department will be different than the task of marketing department. The task of transport department will be different than the task of administrative department or human resource department. So everybody has their own specific set of tasks. So that's the individual component responsibility. But eventually, sales department need to communicate with marketing department. Okay, marketing department might give them the potential customers list where the sales department will make the sale. Okay, administrative department need to keep track of the policies correctly availed or not. HR department need to keep track of how to appreciate the salespeople. So everybody has their own specific responsibility, but eventually at one point they need to communicate. So internal design focuses on their individual responsibility, and when they need to talk to each other, sales department need to talk to marketing department, that's when the relationship comes in. Okay, so every design will always focus on these two aspects. In fact, how well the designer uh, kind of paid attention to this aspect makes the system successful. And these two are formally known as coupling and cohesion. The fact that the design should be individually the component should be individually well designed, that's called cohesion. And the fact that how they should relate with each other, that's coupling. So cohesion focuses on the internal design of the components. Coupling focuses on the external communication or relationship. Okay. So coupling and cohesion, these are two properties of system design. And as a system designer, it is your responsibility to focus on them correctly according to the guideline. The good system design guideline is coupling should be as minimum as possible. Cohesion should be as maximum as possible. High cohesion is desirable, low coupling is desirable. High cohesion means your components are more focused. Okay. Low coupling means the components are only connected on need basis, not unnecessarily connected. So these are the two very important properties of system design. Now let's see the matrices. So the first matrix focuses on coupling. The second matrix focuses on cohesion. So now let's see. Now CBC, coupling between classes. In fact, here we have used it for classes, but it can be applicable to other type of design as well. It doesn't need to be, we used what the word class, that's why it is object oriented. But if you are doing a database, okay, design, there is also coupling over there. If you remember, uh, you did normalization or you did primary key foreign key relationship. So primary key foreign key is basically connecting two tables together. So that's relationship. So that's form of coupling. Okay, so you should only you learned the relational mapping design, which primary key should go in which table as a foreign key. So that you need to follow some rules. I remember like binary one to many, binary many to many, unary. Okay, this kind of based on the type of relationship, uh, the rule was set that which primary key should go in which table. If you do it unnecessarily, then you are increasing the coupling. Okay, then your database will be difficult to maintain. There will be more chances of data anomalies. So my point is, here we are saying class, that's why it is object oriented. But the concept of coupling is applicable to any type of system design. Okay, it is a universal concept. Whenever components will be related, that means because we previously in our previous lectures at some points I told you and you also had MCQs that without relationship there is no interaction. In fact, the type of relationship decides what type of interaction is going to happen. The relationship will definitely be there, but you need to cautiously monitor about when the relationship should be established. Okay, because without relationship, components will not work together, but they should not work unnecessarily together. That means high coupling, and that makes the design more dependent. So now let's read. In case of CBC, one variation that you'll see is Like in DIT and NOC, WMC, we calculated a quantity, but for CBC, it is uh, almost close to impossible to calculate the actual CBC value. So it is always an approximation. Okay. So let's see. Coupling between classes of a system reduces modularity. So they start with the disadvantage of higher coupling. The more a class is coupled, okay, like let's say in this design, class B has got the maximum number of relationships. So that means B is here having higher CBC value, okay, approximately. That means change of B, okay, will affect a lot of others. Or vice versa is change of A, D, E, F will also affect B. So that is one of the disadvantage of higher coupling because dependency increases, modularity decreases. Modularity means the class is more independent. Okay, reduces modularity. More coupling means the class is more dependent, less independent, which makes it difficult to modify. It is desirable to reduce coupling between classes. The less coupling of a class with another other class, the more independent the class, more easily modifiable. Very important points for any system design. So how to calculate? CBC is a metric that tries to quantify. Focus on the word tries to, because sometimes it is impossible. Quantify coupling that exists between classes. Two classes are considered coupled if method of one class use methods of or instance variable defined in other class. There are indirect form of coupling through pointers. I think you have learned pointer programming. So those kind of relationship or coupling is very difficult to trace. Okay, that are hard to identify. So that's why I was telling tries to approximate. Not necessarily you will be able to pinpoint all relationship. Now the data suggests self-contained low CBC values said that's expected design. Some types of classes. Now this is an exception. One of the modern type of system design, particularly for software, is interface driven. Interfaces intentionally is given higher coupling. Okay, interface classes, we studied interface as a component earlier. The purpose of interface is to maintain link. So maintain link means relationship. Okay, like a form, let's say. A form might have link with a lot of your internal classes or tables. So a form is the interface. But the good news is form is not a structural component. Okay, that has got the main code. The main code may be inside your classes, okay, or the main data will be actually inside your tables, not in the form. Form is like a mask. So that's why this we treat as an exception. But it is a fact that interface classes will have higher CBC value because it need to maintain link with many components. And finally, their data suggested that it is significant in predicting fault proneness of a class. Okay. So coupling between classes is a matrix that quantifies how many other classes a class is related with or coupled with. And there are indirect form of coupling through pointers, difficult to identify. Interface classes automatically has got higher CBC value, but it is an exception. And CBC is significant in predicting fault proneness of a class. It is desirable to reduce the CBC values because the more the class is coupled, it becomes difficult to modify the class. The less coupled classes are more independent, more easily modifiable. So coupling between class is a matrix that introduces a very important feature or attribute of a good system design. The last matrix from our this lecture, LCOM, lack of cohesion in methods. I have seen many matrix, OO or general software engineering matrix. So far, from my experience, LCOM I have seen as one of the smartest matrix I have ever come across, because it makes you think from various angles. First of all, it is an inverse matrix. See, while ago, while talking about coupling and cohesion, I said cohesion should be as maximum as possible. High cohesion is a desirable value. Okay, cohesion should be high, coupling should be low. Here, look at the name of the matrix. Lack of cohesion. Our desire is, what we want is presence of cohesion. Whereas this matrix calculates lack of cohesion. So that's why it is an inverse matrix. Okay, it does not actually calculate presence of cohesion. The value it gives us shows us lack of cohesion, which we do not want. That is why the value of LCOM, desirable value of LCOM is 0. That means your design does not lack cohesion. Now, what is cohesion? Once again, to remind you, cohesion is the internal design of a class. Let me come with a different example. Again, we are talking about object-oriented matrix. That's why we are talking about class. But as I said, cohesion is a universal attribute. Doesn't need to be object-oriented. Any kind of system you will find the attribute cohesion, like you did in database. Can anybody tell me what was the purpose of normalization? Did database, I believe. So anybody remember what was normalization? Nobody?
সেম টাইপের অ্যাট্রিবিউটগুলো ক্যান্সেল আউট করার জন্য।
Sorry, I didn't hear you. Again?
স্যার সেম টাইপের অ্যাট্রিবিউটগুলো ক্যান্সেল আউট করার জন্য, যেন টেবিলে এটা রিপিট না করে।
Okay. Everybody agree? I actually kind of, it's been a while I talked about or I studied normalization. So if I remember correctly, in a table there is a primary key. And then there are attribute columns. So name, address, let's say it's a student table, name, address, date of birth. Then let's say another name, okay, course name, okay, a course that the student has taken. But course name is an attribute which does not depend on the primary key of student. So this attribute or this column should not be here. The idea of the, if I remember correctly, that the column that does not directly depend on the primary key column should not be in that table. Okay, because it does not, it's not an attribute of student. Students attributes are student's name, student's address, student date of birth. Course name, even though student has taken a course, but it is actually not an attribute of student. It is an attribute of course. So the idea was inside a component or inside this table, only those elements should remain which works together, which relates to the same item. So only students relevant items should be in the student table. That's a concept of cohesion as well. So normalization is basically a different representation of cohesion, because what end of the day we are trying to do is streamline or remove all the things from a table that is making the table non-cohesive, meaning items that do not relate to each other should not be here. So inside a component, like in our case, a class should have the attributes and properties of this class only. The methods, the operations, okay, the attributes, all should focus on this particular class. If this is a student class, student attributes should be here. Student operations should be here, not a course attribute. Okay. So that's what will make a class cohesive. If there is an attribute which does not belong to this class, should not be here. Okay. If that attribute is here, it will make it non-cohesive. The word cohesive comes from cohesion. Cohesion means focused. Okay. How focused, how targeted, okay, the design of the components are. So when you designed a student class, you are focused to the student only. This class should not be involved in any other responsibility outside student class, like the way you did in normalization. So that should be our target, making the components highly cohesive. Okay, so now let's read. Cohesion captures how closely bound different methods of a class are. Two methods of a class. Okay. So we are focusing the cohesion inside the methods. Look at the name, methods. That means operations. Two methods of a class C, as an example, will be considered cohesive if the set of instance variable they access have some elements in common. This is the definition required for this calculation of outcome in this particular matrix. We are going to declare methods, two methods. That means we are going to take a pair. Two methods will be declared cohesive if they have common variable. Okay. So now let's see how to do it. High cohesion is a highly desirable property of modularity. So we want high cohesion. LCOM is based on an equation. The equation is LCOM equals absolute value of P minus absolute value of Q if P is greater than Q. Otherwise, it is 0. So when the P value is greater than Q value, then this equation is applicable. Otherwise, the LCOM value will be declared as 0. Now, what is P and what is Q? P is the set of all non-cohesive pairs of method. Q is the set of all cohesive pairs of method. So we have to know how to calculate P and how to calculate Q. To make it easy, I have an example here. So let's look at that. This is something you will have to also do it in your assignment, and definitely there will be uh, MCQ questions related to it. So class A, it has got 4 attributes, 4 operations. We are going to calculate the outcome value of class A. First, we need to calculate the P value and the Q value. P non-cohesive pair, Q cohesive pair. First, we create the pair of the methods. Okay, all the pairs of the method. O1, O2 is a pair. O1, O3, another pair. O1, O4, another pair. Then O2, O3, O2, O4, O3, O4. We got 6 pairs. We could have repeated O2, O1. Okay, but this pair is already present. Okay, actually, the total number of pair with these 4 methods can be created is n into n minus 1. That means 3 into 4, 12 pairs. But half of the pair will be repetitive. So that's why we take the half, which is 6. O1, O2 and O2, 1 is actually the same pair for our calculation. So all the repetitive pairs we have removed, and finally what we have is 6 unique pair. Now among this pair, we are going to go each one by one and declare whether it is a cohesive pair or it is a non-cohesive pair. The definition says the pair will be cohesive. 2 methods of a class will be considered cohesive if they have common variable. So if we focus on O1, O2, look at the method O1. The variables they are using A1, A2. And look at O2, the variable it is using A1. So A1 is a common variable. So that means in this pair, there is a common variable. So it is declared as a cohesive pair. Now look at O1, O3. O1 variable is A1, A2. O3 variable is A4. So there is nothing common. This is declared as a non-cohesive pair. So basically, I have color coded. All the blue pairs are cohesive. All the red pairs are non-cohesive. So O1, O4, if you check O1, O4, A1 is common. So that's a cohesive. O2, O3, nothing common, non-cohesive. O2, O4, O2, O4, again A1 is common, cohesive. O3, O4, A4 is common, so cohesive. So if we count, there are 4 cohesive pairs, so Q value is 4, 2 non-cohesive pair, so P value is 2. So the equation says, if P is greater than Q, then P minus Q. But in our calculation, P is not greater than Q. So the outcome value finally we declare is 0. 0 means there is no lacking of cohesion. So the final comment about this design class A is the outcome value of this class indicates that the methods of the class are cohesive and it is a desirable design. So the design of class A is desirable. That means the class is cohesive. Okay, so I don't know how much you followed. Not very complicated, but a very interesting way to look at it. Rather than directly trying to find out whether the class is cohesive or not, it has taken an indirect approach. Now let's read the rest of the lines, how it relates to other elements. Larger the number of cohesive method, the more cohesive the class will be. As you can see in our example, we had larger number of cohesive methods. So the outcome value will be lower. A high outcome value, this is an interesting point. If your calculation indicates that you have got a high outcome value, let's say 5, 10, something like that, may indicate that the methods are actually trying to do different things and operates on different data items instead of working together, instead of working on the common data items. If this is validated, okay, that means if this is found true, the class can be partitioned into different classes. So one of the suggestion for high outcome class would be to break down the class, okay, come up with 2 or 3 different classes so that the outcome value comes down, so that they become cohesive. And as per the data, it was found not very significant, little significant in predicting fault proneness. Now, this is the article. Okay, if you search in Google with BBM95, you will actually find the survey and all the articles based on which these metrics are actually created. So this is CBC and LCOM, based on which you are supposed to have a quiz in the next class, but unfortunately, the next class is on next week. So Wednesday is a government holiday. So our plan will be bodily shifted. I was thinking of having the comprehensive quiz on 25th, 26th, but now it looks like it will have to go on 28th. No worries, we have time. So your next quiz is basically CBC and LCOM on 19th Monday, where we will also start our new topic, which is, in fact, uh, no, it's okay. No, we're not going to start new topic today. So that's your matrix, double O matrix done. Part 2 is LCOM and CBC. These two actually introduces uh, concepts beyond object orientation. We have adapted them in these two matrices, focusing object orientation. But if you understand the inner concept, that is applicable to any part of anywhere. In fact, wherever you work, whether it's a software company or it's a business organization doing any kind of business, this concept of component working together, you will definitely experience. And if you're the one designing, if you focus on them carefully, guaranteed that your system will be more flexible than anybody else. So from CBC, usually we do not have any diagram based question, even though I tried to give a summary here. Okay, but as you can see, it's an approximation. So from CBC, the MCQ questions are more on kind of from the lines, okay, from the understanding. But from LCOM, there can be a case study based question. I might give you a class design and ask you to calculate the LCOM value or P value or Q value, things like that. And also for your assignment, you have to calculate LCOM value of 2 classes. The last point, if you check in the guideline. And not only that, you have to make a comment as well based on the LCOM value. So the comment is if it is 0, then it is a desirable value. If it is, let's say, within the range of 1 to 5, okay, it is desirable to reduce it. If it is within the range of greater than 5 or more, then you have to declare it as a non-desirable design and the class design need to be revised. Okay. So that's it for today. Anybody has any query regarding anything?